So let's do a video about flame sensors, alright? So I have a gas furnace here, and it has a flame sensor. So the thing with that red spade going to it is a flame sensor. This up here is an igniter. So what happens is, when the furnace tries to ignite, the igniter glows red hot. This is a hot surface igniter. And when the gas valve opens and allows gas through these orifices right here, the burner should ignite and the flame should travel through the channels downward all the way down to the flame sensor. And so you can see that metal little rod right there. It sits in the flame, right? And it's not a thermocouple. So the way this flame sensor works is completely different than a thermocouple. So a thermocouple sits in a flame and it generates a small voltage. The way that this flame sensor works is that it uses, so flames are conductive, and you can flow current through a flame. And the flame sensor takes advantage of that. It's something called flame rectification. So with the way that the flames are ionized, it almost behaves like a diode. So current will travel more readily in one direction than the other. And so if you check the voltage, the one thing I'll tell you too is not to touch the wire on that flame sensor, okay? Because you'll see here in a second why. So what I'm going to do is check the AC voltage here on that flame sensor, and it has 32 volts. Now that's a little bit tame, but some of these actually run at 90 volts. You don't want to touch that because it would shock you. So, but the train furnaces seem to be a little bit more tame with the voltage they use here. So you have this alternating current that actually goes, if I actually check the rod of the flame here, it's present on that rod as well. Hopefully I didn't burn my meter lead up, but yeah. So you have AC voltage sitting on that. And what happens is there will be a small current flow through the flame into the ground. So the flame is touching the ground and the burners and everything. And that's one reason why grounding is so critical on gas furnaces. Because if you don't have a good ground, then the current has nowhere to go and it's not going to prove a flame. So in order for current to flow through the flame into ground and get rectified properly, you have to have a really solid ground on a furnace. You notice they've got a grounding lug right there for it. And yeah, so I've had furnaces before that just won't fire because of that. So the way that you can test this flame sensor to see if it works or not, and since this is only 31 volts, I feel pretty comfortable just pulling this off here, and that'll cause the flame to go out. All right, and what I'm going to do is put this lead onto the flame sensor, and I'm going to put my other lead, I'm going to put my meter into microamps DC. Flash makes it hard to read, of course, but we're right here. And I'm going to put my other lead into the spade terminal right here. And normally when these work right, you should have about 2 or 3 microamps of current. Now you can see it's negative. I'm not concerned about that because I have the red lead. It's just due to the polarity of my test leads. The only thing we're worried about is the magnitude of the current. And so 2 or 3 is what most furnaces are designed for. If that current goes too low, then you will, you may have intermittent ignition. Even though it ignites, it may not prove the flame properly. So yeah, that's one thing you can do on maintenance, is to make sure, because these flame sensors, they've got a rough life. They're always sitting in flames, and eventually you get carbon buildup on them that will reduce that amount of current, and the board may not sense enough current to prove the flame and keep the furnace running. So yeah, that's my spiel for today, boys.